Welcome to Educator.com. Today's lesson is on factoring using the greatest common factor. So in order to do this, we're going to be applying the distributive property. Recall that the distributive property says that A times B plus C equals AB plus AC. Now, when we move forward from left to right, that's simply multiplying. We're just multiplying out A times B plus C. When we move from right to left, that is considered factoring. And that's what we're going to be doing for this and the next several lessons. So let's look at how we can apply the distributive property to write a polynomial as the product of its greatest common factor and a simpler polynomial. Starting out with just a binomial, because that's very easy to work with. If I have 6x squared plus 9x, I'm going to first look for the greatest common factor. And recall that the greatest common factor is the products of the common factors of the two terms that you're working with. So the greatest common factor here, if I look at the numbers, I have a common factor of 3. And if I look at the variables, I have a common factor of x. So I want to write this now as the product of the greatest common factor times some simpler polynomial, in this case binomial. Therefore, I can rewrite this as the greatest common factor 3x, and in the parentheses I'm going to put what was left behind when I removed the greatest common factor. So if I take 3x out of 6x squared, that's going to leave behind 2x. If I take 3x out of 9x, that's going to leave me with a 3. And you can easily check your work by multiplying out. So I went from AB plus AC to A times B plus C. Now I can check what I have here by multiplying out, by going back and using the distributive property. 3x times 2x is 6x squared, and 3x times 3 is 9x. Applying this to a slightly more complex expression, a trinomial. Now, I need to look for the greatest common factor, and when I look at the numbers, the greatest common factor is going to be 2, because I have a 2, 12 is divisible by 2, as is 8, as is 6. For the variables, I'm going to look at the exponent of the x that is the smallest exponent. So I have the same variable, and x squared is the smallest exponent I have. So I know that there's going to be at least an x squared in each of these. My greatest common factor is 2x squared. Okay, so looking at what I have my greatest common factor, 2x squared, and I'm going to then write a simpler polynomial with the terms that are left after I pull out the 2x squared. So if I take 2 out of 12, that's going to leave me with 6. If I take x squared out of x to the 4th, that's going to leave me with x squared. Plus, taking 2 out of 8 leaves me with 4. X squared out of x cubed, that gives me 4x. And then here, make sure you keep your sign straight. This is a negative sign, and I have a 6x squared. Pulling 2 out of that leaves me 3, and no x's will be left. Again, I can check my work. 2x squared times 6x is 12x to the 4th. 2x squared times 4x, 8x cubed. 2x squared times negative 3 is negative 6x squared. So this is the basic principle, and we're going to be using this throughout factoring. Okay, another concept that we're discussing is factoring by grouping. Factoring by grouping is often used when you have a polynomial with 4 terms. And in this case, you're actually going to be using the distributive property twice. This is most easily understood by seeing it done and looking at an example. So let's look at an example of this polynomial with 4 terms. So following the principle here, first I'm going to group each pair of terms. By group each pair of terms, it means put 2 terms together. So I'm going to put the first 2 together and the second 2. So first, group each pair of terms. I'm grouping 3x cubed and 4x squared plus 6x minus 8. Okay, group each pair and factor a common factor. So I'm going to take my first pair. My first pair is right here, 3x cubed minus 4x squared. So let's work over here and show what's happening. 3x squared cubed minus 4x squared. So I need to find a greatest common factor. Well, I don't have a common factor between 3 and 4, but I do have a common factor among the variables. I have x squared. That's my greatest common factor for this first set of terms. So I go back and I'm going to write this, just as I discussed in the last slide, as the product of this greatest common factor and what is left behind. So I have an x squared that's going to leave me with a 3 and an x. For the second term, it's just going to leave me with a 4. Okay, so this was my first group. For my second group, I have 6x minus 8. So I want to find the greatest common factor there. And I look between 6 and 8, I do have a common factor of 2. I don't have a common factor with the variables. So all I can pull out from here is a 2. Well, 2 times 3x would give me back 6x, and 2 times 4 would give me back 8. Okay, so I've factored out my common factor. Then factor a common binomial factor. So this is the new step. Now, I use the distributive property in order to pull out or factor out my greatest common factors. Now I need to use that property again to pull out a common factor. And we're used to thinking of a common factor as just a single term rather than an expression. So I use the distributive property, and I know that AB plus AC can be expressed as this. Now, A does not have to be just a term, a number, a monomial. It could be a polynomial. So here, if I look at it this way, this is my A. This is A. This is B. This is C. I can factor out that entire binomial. So when I do that, I'm going to pull that out, 3x minus 4, since these are the same. And that is going to leave me with x squared plus 2. Okay, so in order to factor a polynomial with 4 terms, the approach is to group the terms, 2 first terms and the 2 second terms. Then factor a common factor from each pair. So I factor out x squared and I factor out 2. And then hopefully what you'll have left behind is a common binomial factor. Here was 3x minus 4. Now I'm factoring that out, and I'm putting that in front. We usually put what was factored out first. So that's 3x minus 4 plus x squared plus 2. Okay, we've talked about factoring some expressions, and factoring can be used as an initial step in solving an equation. So what the zero product property does is it tells me that if I have the product of 2 terms equals 0, then one of the terms must be 0, or they both must be 0. Because in order to get a product that equals 0, either A is 0, then 0 times B would be 0, or B is 0. 0 times A would be 0. This knowledge allows us to solve equations through factoring. For example, let's say that I was given an equation and I already factored it out, and I came up with this. So I was given an equation and I went ahead and did the factoring. And I have it in this form where it's equal to 0, where the product is equal to 0. Well, I know that this is analogous to AB equals 0. Therefore, A must be 0, or B must be 0, or they both have to be 0. That's the only way I'm going to end up with a product that equals 0. So I can use that knowledge that A equals 0, or B equals 0, and apply it here. 3x minus 6 equals 0. I also know that 2x plus 4 may equal 0. Then you just go ahead and solve just like you're used to solving equations from past lessons. So I'm going to go ahead and isolate the x by adding 6 to both sides. And then I'm going to divide both sides by 3 for this first equation. For the second equation, I'm going to subtract 4 from both sides. And then I'm going to divide both sides by 2. What I've come up with is two solutions for x. X equals 2 and x equals -2. So this is my set of solutions. I have two solutions here, and I was able to do that by applying the zero product property. Okay, in our first example, we're factoring an expression. We're not onto equations yet. We're just going to factor an expression. So the approach is going to be to first find the greatest common factor. So I'm going to look at my numerical terms, and I have 6, 18, and 36. The common factor there is 6. All of these that's the greatest integer that all three are divisible by. Okay, looking at the variables. I'm going to look at my x's, and I'm going to find the one with the smallest exponent, and that's x squared. So that's the smallest exponent, so the others contain x squared plus more. So I know that I have an x squared in each of these terms. Next, I go on to y cubed. Okay, so that's y cubed. I have y squared and y to the 4th. My y term with the smallest exponent is y squared. And finally, the z terms. Z to the 4th, z to the 3rd, z to the 6th. This is my smallest exponent. So my greatest common factor is 6x squared, y squared, z cubed. Now, write the polynomial as a product of the greatest common factor and a simpler polynomial. So I have my greatest common factor, 6x squared, y squared, z cubed. I'm going to see what remains after pulling that expression out of each of these, and I'm going to write that here as a simpler polynomial. Well, if I take the 6 out, then that would just leave me with a 1. X squared, no x's remain. If I take out y squared, I'm going to have 1 y left, and z cubed is going to leave me with just z. If I take 6 out of 18, 6 times 3 is 18, so I'm left with a 3. X squared out of x to the 4th leaves me with an x squared. Y squared, no y's left. And z cubed, no z's left. 6 times 6 is 36, so I'm left with a 6. X squared into x cubed, that leaves me with x. Y squared, taking that, factoring that out of y to the 4th, leaves me with y squared. And then z to the 3rd, taking that out from z to the 6th, leaves me with z to the 3rd. Okay, so now I have expressed this trinomial as a product of the greatest common factor and a simpler trinomial. And I can always check my work by multiplying this back out. And if I do that, I'll see that I get back my original expression. Okay. In the second example, I see that I have a polynomial with 4 terms. So we're going to use the grouping method. Remember, first, you're going to group the first 2 terms and the second 2 terms. And this is when I have a polynomial with 4 terms. I'm using the grouping method. So I'm going to group 3x squared minus 6xy, and I'm going to group -4xy plus 8y squared. After I have grouped these, I'm going to find the greatest common factor for each group. Okay, for my first group, let's find the greatest common factor. And I look and I have a 3 and a 6, so I can pull out a 3. That would be my greatest common factor for this first group. So for 3x squared minus 6xy, the greatest common factor would equal 3. And then I look and I have an x in both. That's the smallest exponent is 1, so x. And then I'm looking and I don't have a y term in both, so I cannot factor that out. So the greatest common factor for this first grouping is 3x. For negative 4xy and 8y squared, numerical, the greatest common factor would be a 4. And I look, I only have an x in one term, can't pull that out, but I have a y in both. I have one y in both. So the greatest common factor for my second group is 4y. Now I'm going to express these as the product. So express each group as the product of the GSF and a binomial. Okay. So for this first one, my greatest common factor was 3x. That is going to leave behind only an x. If I pull 3x out of this, I'm going to get a negative 2y. And I can always check that by multiplication. 3x times x is 3x squared. 3x times 2y is negative 6xy. Okay, for this second binomial, I've factored out 4y. What I'm going to have left behind is simply negative x. For my second term, I'm going to have a 2 left behind and y. Okay, the next thing I want to do is factor out a common binomial. Remember that we're using the distributive property twice. I used it once to pull out the GCF, and I'm using it again to factor out a common binomial. I look here. The problem is I initially look at it and say, maybe I don't have a common binomial. X minus 2y and minus x plus 2y. But I can work with this so that they will be the same, because the only difference here is the negative sign. What I can do actually is factor out a negative 1 from either one. And what I'm going to do is actually factor out a negative 1 from the second expression. So I'm going to end up pulling that negative 1 out, and this is going to give me negative 4y. And when I pull out the negative 1, the x becomes positive, and then this second term is negative. So I'm going to rewrite this a little bit simpler. Now I have a common binomial term. What I'm going to do next is to pull that out. I'm going to group the 3x minus 4y and group that with x minus 2y. And I'm going to change the order slightly because we usually write the term that was factored out in front. But either way, comes out with the same. And if I wanted to check my work, I could just multiply this out. Remember, using the FOIL method, I could multiply the first two terms, so I could use FOIL to check my work. The first two terms multiply, that would give me 3x squared. The outer two terms would give me negative 4xy. The inner two terms, negative 6xy, and the last two terms plus 8y squared. I compare that to my original. I have the 3xy. It's in a little bit different order, but it's the same. These two are reversed. It's the same expression, plus 8y squared. Okay, so this was pretty long and complex. So when you're factoring a polynomial with 4 terms, use the grouping method. That is one method you can use. Group the first two terms and the second two terms. Then find the greatest common factor from each group. I did that. And then I expressed each group as the product of its greatest common factor and a simpler binomial. I had to do an extra step here because I had to factor out a negative 1 in order to get these two in the same form. Once I did that, I had a common binomial that I factored out to get my final factored expression. have another expression. Again, this is a polynomial with 4 terms. So I'm going to use grouping. Group the terms. Group the first 2 and group the second 2. 12x cubed minus 6x squared. And then I'm going to group negative 5 and 10x. Next, find the GCF for each group. Okay, let's look at this first group. Let's do it over here. 12x cubed minus 6x squared. The greatest common factor for the numbers is 6. And I notice that I have an x squared and an x cubed. So the greatest common factor there is going to be x squared. Okay, for my second group, negative 5 plus 10x. Greatest common factor for the numbers would be 5. No common factor for the variables. So my greatest common factor for the second group is 5. Third, write each group as the product of the greatest common factor and a simpler binomial. Okay, so for my first group, greatest common factor is 6x squared. If I take a 6x squared out of 12x cubed, I'm going to leave behind 2x. If I take a 6x squared out of 6x squared, I'm going to have a 1. It's not just 0 or nothing. You still have a 1 left behind, because if I multiplied 6x squared times 1, then I would get 6x squared back. For my second expression, I have greatest common factor of 5, which is going to leave me with a negative 1 plus 2x. Now I want to factor out the common binomial. So I'm looking at this, and I actually do have a common binomial. This second one is just written in the opposite order of the first one. So I'm going to rewrite that a bit differently so I can easily see what I have. Instead of writing negative 1 plus 2x, I'm just going to write 2x minus 1. And once I do that, I see that I have a common binomial. And I'm going to pull that out, and it's going to leave me with 6x squared plus 5. So the factorization of this polynomial with 4 terms was achieved by first grouping the first 2 and the second 2 terms, finding the greatest common factor for each pair, and then factoring out the common binomial. Okay, in the fourth example, we have an equation. So we're going to apply the zero product property that we learned. And this is already in a nice, easy factored form. Sometimes, however, you'll actually have to do the factoring first, and then you'll use the zero product property. Reviewing the zero product property. The zero product property tells me that if I have a product, AB equal to 0, that A equals 0 or B equals 0, or they could both equal 0. So one or the other of these must be 0. With that knowledge, I can say that 2w minus 7 equals 0. And I can also say 3w plus 8 equals 0. So I have these two equations. Now I'm just going to solve the equations. So 2w minus 7 equals 0. Add 7 to both sides to get 2w equals 7. Then divide by 2. So just using the skills that we learned in earlier lectures under solving linear equations. So if you need review on that, look on the earlier lectures about these skills. So now I have w equals 7. Divide both sides, 2w equals 7, divide both sides by 2 to get w equals 7 halves. I have a second equation. 3w plus 8 equals 0. Subtract 8 from both sides. So I'm trying to isolate the w. Divide both sides by 3. So I have two solutions here. My solution set would be that w could equal negative 8/3. And w could also equal 7 halves. These are the two solutions for this equation. And I was able to solve this equation by applying the zero product property, which tells me that if I have the product of two terms, one of those terms must equal 0 in order for me to get an inequality that is 0. Okay, so today on educator.com we went on to do some factoring, and I will see you again for the next lesson when we do some more advanced skills with factoring.